class, these are our student notes for the week. This is the wedge and the wedge notes, and the wedge we can see is the first definition there, and the wedge is a mechanism that contains two inclined planes in motion, changing a forward force to a parting force. As you can see there in our little diagram, the wedge is moving forward or down into the wood or whatever that is, and it is parting it. It is pushing it apart. So we have a forward force to a parting force. And this is a wedge that is made up of two inclined planes. Go ahead and get that definition filled in. A mechanism that contains two inclined planes in motion, changing a forward force to a parting force. That part that says in motion is what really makes a wedge different than an inclined plane. Most inclined planes are stationary, and wedges are moving things. At least most of the time. Okay? We will see in the 3 ways to use a wedge, one of the ways is actually not in motion, but is holding an object. So you can think of this as a wedge that holds a door open. There are a lot of wedges that you stick in the bottom of a door and it holds the door open. You can also think of this if you put wedges behind the tires of something so it doesn't roll down a hill. That is an example of holding an object. A wedge holding an object. Number 2 here is to cut an object. And when I say cut, you may automatically think of a knife, because a knife is used to cut. And the blade of a knife is a very small, but it is a wedge. So anytime you see a knife, then you will know that there are that the knives are made of wedges and they are made to cut. Number 3, push an object apart. This is what you see happening in both of these pictures. The wood or the brown thing is being pushed apart by the wedge. Okay? Next we see here our example of the formula. MA, meaning mechanical advantage, equals length divided by width. And if you were to use the numbers that are here with our diagram in the middle, 15 centimeters is the length and 3 centimeters would be the width. 5 centimeters would be the width. So 3 would be your mechanical advantage for this little example here in the middle of the page. Another way to say the mechanical advantage is input distance and output distance. The distance that the wedge is going to go into the wood, so that is the same as the length. The distance, because if you're going to push the wedge the whole way into the wood, then the length is the input distance. The width, the output distance, is how far apart that wedge is going to push the log apart. Okay? So mechanical advantage equals L, input distance, divided by W, output distance. You can think of the L and the W as length and width. Another way to write this formula is output distance equals input distance divided by mechanical advantage. And the last way to write this formula is input distance equals mechanical advantage times output distance. These will be the three formulas you will want to use for your homework. Now let's go over a few things to remember. A wedge is made up of two inclined planes. Most commonly, a wedge is used to push things apart. A thicker, shorter wedge will split things apart faster. You'll have to push down on it with more force. Okay, so a thick, short wedge will split things apart faster, but you'll have to push down on it with more force. All right, the last one there. A thin, long wedge will be easier to drive in, but will take longer to split something. Okay? It takes less effort with a longer, thinner wedge. All right, the next two sections here are going to be done in your experiment videos, but make sure that you write in your hypothesis of which wedge do you think will be easier to part the wood. Okay, so you can go ahead and move on to, actually before you move on to your formula, I want to discuss one more thing. Causes of error. One cause of error is friction. Friction is when the surface you are on has a big effect on your experiment. We did an experiment with friction, and we came to find out that friction has a lot to do with surface area, because the surface area of the marbles was greater than the surface area of the pipes. That made the friction greater. So friction has a lot to do with surface area and what you're on or what you're trying to pull or drag, and that can cause error in your experiments. This is why many of our homework problems are hypothetical, frictionless environments. When you do your homework, oftentimes in order to see the ideal, we pretend that there is no friction. All right, the next error is human error. And let me get the slide. It's a little out of order here. Human error. This can be seen when we don't set up any experiment, when we don't set up an experiment properly, or when we make mathematical mistakes. If we are setting up an experiment and it doesn't, we don't do something right, then this is caused by human error. If we don't measure correctly, or if we switch our numbers around and don't write them down in the right order, or if we simply just cause something to break due to our own neglect. This is human error. This is why we use calculators when we need to. Now, if you look up there at the top, mechanical advantage or mechanical error, this can be seen when a device we are using is not working correctly. I have had in the past a lot of trouble with my spring scales. This is why I always double check our scale is beginning at 0 when we begin to measure the force needed with someone. It is very important to make sure that our mechanics and the tools that we are using are working properly. So these are 3 out of 4 errors, and next week we will discover the 4th error. So we have friction, human error, and mechanical error. These are all 3 causes of error.